Okay, this is a little update on the linear table that I'm building. This was the first original build. It has the acrylic base plate and then of course the good aluminum optical plate. This one was hand drilled by me, and you can see that where it's countersunk it's different, and I didn't like the way that was going. I made a few changes on the first actual, I would consider production one that I'm doing. I'll show you in just a second. This has a 700 millimeter actuator. However, we only really need about 300 millimeters of travel to be able to make use of this entire bed. And I actually went from 700 millimeter travel because you see how far this sticks out on either side of this Aurora to a 500 millimeter. This is essentially the same design. It's the same type of linear actuator. I already have the cable pre-made and everything for it. This is the same 200 by 600 by 12 or 13 millimeter optical plate that's on here, and I did have a machine shop drill and countersink the screws, and I have it covered with tape right now to protect it. It has the acrylic base also, and I have tape on it, of course, to protect. One thing that I've added to this one that I'm fixing to test and make sure is I've added an end stop switch on either side, so that if the bed travels all the way to the end, there will be a way for it to stop and not keep trying to go and tear up a belt or something. This is going to be all, this is not going to send any information. These end stops will not send information to the laser, so you can't use it for positioning or zeroing or homing or anything like that. All this is going to do, since we have an integral driver here on this motor, is attached to the alarm signal, so that if either switch is pressed, it just interrupts the function of the motor and makes it quit turning. And that's all it does. So it's just a fail-safe, so that it doesn't keep going if it hits one of these switches. So I added that as just a little feature to help with that. Just in case you get it programmed wrong, try to send it farther than its intended range of travel, you'll have some recourse there so that you don't damage the unit. So this is pretty much together. I've got to finish wiring. I'm waiting on some more stuff to come in to wire the switches in, and then I'm going to document and take pictures and also add switches to this one, because I'm going to use this one as my diagnostic and the one that I do instruction with, because it's close enough to this actual production unit, quote unquote, that I think it'll be fine. So I'll give you a little bit more of an update after I get the switches in and get those all checked, get them wired. I want to test it out, and then I still need to work a little bit on the manual doing continuous marking. I've got the batch marking all figured out, but I haven't actually tried a continuous marking where you do one long continuous engrave, and that's something that I still need to work on, so that I can have some instruction for that in the manual. That's where we're at so far. Just wanted to give an update.